Alright, this is Unit 12, Magnetism and Electromagnetic Induction, Subunit Alternating Currents and Transformers. So, in this video, I will be applying the transformer equation to solve problems involving step-up and step-down transformers. So, the transformer equation is shown here. Induced EMF in the secondary, which is shown here, equals number of turns in the secondary over number of turns in the primary times applied EMF in primary. All shown here. All shown here. Excuse me. So the first problem we have is a step-up transformer is used on a 135 volt line to provide potential difference of 3200 volts. If the primary has 87 turns, how many turns must the secondary have? So we are given the applied EMF in primary, it's 135 volts. We are given the induced EMF in the secondary, which is 3200 volts, and the number of turns in the primary, which is 87 turns. So we have to find the number of turns in the secondary. We can rewrite the equation as number of turns in the secondary equals induced EMF in the secondary over applied EMF in the primary times number of turns in the first. So plug everything in. Number of turns in the secondary equals 3200 volts over 135 volts times 87 turns, and the number of turns in the secondary is 2062 turns. So that is the first problem. The second problem involves a step-down transformer. A step-down transformer providing electricity for a residential neighborhood has exactly 1,973 turns in its primary. When the potential difference across the primary is 4,674 volts, the potential difference at the secondary is 150 volts. How many turns are there in the secondary? So again, we're given applied EMF in the primary, which is 4,674 volts, induced EMF in the secondary, which is 150 volts, and number of turns in the primary, which is 1,973 turns. And we're solving for number of turns in the secondary. So we use the same reworked equation, and we plug everything in, and we get number of turns in the secondary equals 150 volts over 4,674 volts times 1,973 turns. And that gives us the number of turns in the secondary, which is 63 turns. So that is Unit 12, Alternating Current Circuits and Transformers 2. And that is it.